Hello and welcome to another episode of the Atom Chronicles. I'm David, your go to guy for all things atomic. How are you today, Emily?
Hey, David. I'm doing great, thanks. Just trying to wrap my head around all these atoms. The things that make up everything in our universe.
Exactly. It's fascinating, isn't it? Today, we're diving into the history of the atom and exploring some monumental ideas and characters in science.
Absolutely. So, where do we start? I believe we are going way back to the year 460 BC with a guy named Democritus.
That's right. Democritus is often regarded as the father of atomic theory. He proposed the idea that everything in the universe is made up of tiny, indivisible particles he called atoms, which literally means cannot be cut in Greek.
Wow. It's like he's the grandparent of every chemistry lesson we've had. But how did he come to that conclusion?
Great question. Democritus thought about the world around him, and through philosophical reasoning, he envisioned all matter being composed of these small particles. Pretty groundbreaking for his time.
Impressive. But I also love the way the narrator cheekily tells Democritus he has a nice beard. It adds a bit of humor to science.
Definitely, some lightheartedness can make such serious topics more approachable. Now, fast forward about 2,000 years, we meet John Dalton in the late 1700s. Dalton refined and added to Democritus's idea.
Right, Dalton introduced the notion that atoms are not only indivisible, but also cannot be created or destroyed. And he even talked about how they combine to form compounds.
Exactly. For instance, water is formed when a hydrogen atom bonds with an oxygen atom. However, Dalton did miss some details about the nature of these bonds.
That's where J.J. Thomson comes in, right?
You got it. Thomson introduced the idea that atoms are made of smaller particles, namely electrons. He likened atoms to a plum pudding, where electrons are the plums scattered throughout the pudding.
And who wouldn't want to eat that science dessert? But what did Rutherford contribute that shook things up even more?
Good segue. Rutherford discovered that atoms consist mostly of empty space, with electrons orbiting around a dense nucleus. This was a huge shift from the previous concept of atoms being solid spheres.
So it's like finding out that most of your favorite snack is air. But then we have Niels Bohr, who took things even further.
Yes, Bohr found that electrons actually occupy specific energy levels, or shells, rather than just floating around aimlessly.
Every time I learn this stuff, I think about how connected science is to world events. Bohr's work helped lead to the atomic bomb, which he reflected on with such gravity.
Exactly, Emily. And that whole great power comes with great responsibility concept resonates even in today's scientific explorations.
Speaking of which, I love how Democritus tries to lighten the mood with a joke about losing an electron. Can we share that?
Of course, Democritus jokes, two atoms are walking down the street. One says, I think I've lost an electron. The other asks, Are you sure? To which the first one replies, Yes, I'm positive.
Hilarious. It's great to end on a witty note. So, to wrap things up, what are our main takeaways?
The journey of atomic theory has shown us how our understanding has evolved, starting from Democritus to Bohr. Each scientist built on the ideas of those before them, contributing to our current understanding of the atom.
Exactly. And I encourage our listeners to check out the historical details in the document we're discussing today, because there's so much more to explore.
Before we go, a quick word from our sponsor. If you enjoy these podcasts and want an uninterrupted experience, consider upgrading to a paid plan with Reina AI. No ads and full focus on our atomic adventures.
Well worth it. Thanks for joining us today, and we'll catch you next time for more fascinating topics.
Stay curious, everyone.
Goodbye.